Hello everyone, I'm Joseph here again, Assistant Professor, Assam Downtown University. So today I'm going to discuss about this redox titration. So redox titration also you can say as oxidation reduction titration. So oxidation and reduction usually occurs simultaneously in a reaction, one substance becoming reduced in the process of oxidizing the other. So oxidation can be defined as the addition of oxygen to any substance, and you can say a removal of hydrogen from any substance, and you can say loss of electron from species. Reduction can be defined as the addition of hydrogen, so it is opposite to the oxidation. So addition of hydrogen to any substance or removal of oxygen from any substance and gain of electrons from the species. So reducing agents are there. A reactant which loses electrons in an oxidation reduction is called as a reducing agent or reductant. Some examples are like hydrogen peroxide, ascorbic acid, oxalic acid, ferrous ammonium sulfate, and sodium thiosulfate. These are the example of reducing agent. And some oxidizing agent are also there. The electron lost by the reducing agent gained by the oxidizing agent or oxidant. So some example involved in this oxidizing agent. Here you can see this is potassium permanganate, ferric ammonium sulfate, this potassium bromate, potassium iodate, iodine, and bromine. These are some example of oxidizing agent. So some classification of redox titration are like permanganametry, cerimetry, iodimetry, iodometry, and bromometry. These are some classification. These are some types of redox titration involved. So first one we have this permanganametry. So titration involving potassium permanganate. So permangana from name you can see here permanganametry means involve potassium permanganate. So potassium permanganate is a valuable and a powerful oxidizing agent. So when a potassium permanganate is used as an oxidizing agent under its acidic condition, the following equations are involved. Like here you can see this KNO4 this potassium permanganate react with sulfuric acid and formation of K2SO4. You can see the reaction involved here for this permanganametry. And in the cerimetry, it is the titration involved of ceric sulfate. So ceric sulfate in the presence of dilute sulfuric acid of 1.8 normal, it is a powerful oxidizing agent, and the acid must present in sufficient amount to prevent the hydrolysis and the precipitation of basic salts. And ceric has only one oxidation state as follows. You can see here this oxidation state in the reaction, and the ceric sulfate is bright yellow in color both in solid state and solution, and ceria salt form on the reduction is colorless. So as a practical oxidizing agent, ceric sulfate has many advantages over permanganate and dichromate. Like solutions are stable on boiling and do not need protection from light, and react quantitatively with oxalate, arsenite, sodium oxalate, or arsenic trioxide can be used as primary standard. And ferrous ion is colorless and does not interfere with the indicator. So no intermediate products are formed in the reduction of the ceric serum. Thank you.